This is just an intro to sort of the science of physics. It's that normal first chapter. We're going to go through the first part of this really fast. Now I am realizing that I've got a large number of people in this class, none of whom are here today, who have not had conversions or sig figs, so we will spend a little bit more time on that than we would otherwise. Those of you who've already had that, I'll have some other stuff for you because I don't think you'll need the level that they will. What is physics? Well, the snotty physics people say it's the science you can do stuff with. I majored in biology. My minor is in chemistry. I got through physics, and that's about the best I could say. I cried when they told me I was going to have to teach it for the first time. Literally, went home and cried. But the cool thing about it is physics is the underlying why for everything that happens in chemistry and biology. So biology is descriptive. Biology and geology are descriptive. We're describing living things or non-living things. Chemistry explains chemistry explains what happens in those living things or what happens in those non-living things, the inorganic parts of chemistry. Physics underlies why it all happens. So even at the atomic and subatomic level, physics is what explains how that stuff works. And we break it down into a bunch of areas, of which we will do 2. I wish we could do more. We don't get there. So the areas of physics that the area we're going to spend the most time on is just straight up mechanics. And the thing that people confuse is mechanics and quantum mechanics. Not even close. Mechanics is classical Newtonian mechanics. So this is the Newtonian stuff. And this is what we call kinematics, which is the study of motion. This is analyzing motion. This is doing velocity, acceleration, all that sort of thing. The mechanics are forces and frictional forces, applied force, net force, all of that. Mechanics is going to include work and power, that sort of thing. That whole chunk, kinematics, forces, and work, is going to take us through February, amazingly enough. I would love to do thermodynamics. In my dream world, I have my physics kids build solar hot water preheaters and test their efficiency, but we're never going to get there, so that's right out. Vibration, we'll talk a little bit about it, but we don't have the time to talk about thermodynamics here. And again, my goal is to get you ready for a first year of college physics. I can't get you ready for a whole engineering curriculum. So I try to get the stuff that you're going to see in that first year of a college physics program. Vibrations and wave phenomena we used to do. It's probably the part that you've already had the most exposure to, and it's the part that is easiest to pick up on your own. If you walk in having not had that, and you walk into a college physics 102 or 502 or whatever they call it, and you have to learn that from the get-go, you'll survive. Not so much with kinematics and forces. So we don't really do that. We used to do optics. They removed it from the state standards. So I threw out all my optics stuff. Again, that's also something that's easier to pick up sort of from scratch. Electromagnetism is the other piece that we're going to do. And this is electricity and magnetism. We will do some basic Coulomb's law. Let me put that on there. Coulomb's law, stuff with basically charge and forces between charges. If we're able to, and this year I think we have a good chance. Last year we were cut so short. We'll do some introductory circuit work. So usually in the past I've had my physics students solder, and we've built circuits. I have kits here. You can build a little robot. It's kind of silly. You put a battery in it, and you turn on something, and it jiggles on the table. It's not all that exciting, but the lights flash. So, woo! Now, these last two areas of physics, relativity and quantum mechanics, we don't do. That's the sexy physics. That's the stuff that makes people go, wow, that's so deep and interesting. Nothing that we're going to do here is deep or interesting. It's all pretty pedestrian. It's all just how the physical world works. Relativity is the Einstein stuff, good old Uncle Al. Quantum mechanics is a little bit weirder. So, from chemistry, you may recall the quantum model of the atom. You may not recall it. It's okay. I'm not going to expect you to recite it right here and now. But the quantum model of the atom arises because we couldn't explain everything using normal mechanics. And so the quantum model takes stuff from Einstein, it takes stuff from de Broglie, it takes stuff from Heisenberg and Schrodinger, mushes it all together into this lovely lump of dough, and gives us the electron configurations that we're familiar with 1s2 and 2s2 and all that stuff. Quantum mechanics comes in because the normal laws of mechanics, the gravity and attractions and forces and interactions that work at the macro level, you smack a baseball with a bat, you know how it will behave. You drop an object near the Earth's surface, and you know how it will behave. Unfortunately, when we get down to the quantum level, when we get down to the subatomic level, things don't behave exactly the way we would predict using classical mechanics. So quantum mechanics deals with the subatomic level of matter. It is down at that very, very, very low level. We don't do that here. If you take the 7 Great Ideas class at Kent, they do some quantum mechanics stuff, quarks and charmed and up and down and sideways. That's not real. I made that one up. Up, down, and charmed are, and I think, is there weird? I don't do subatomic physics. I'm a biologist with a lot of chemistry behind me. We will not touch any of that stuff. So don't confuse quantum mechanics and mechanics. Mechanics is Newtonian, quantum mechanics is subatomic. That's Einsteinian, I guess. Questions on this? We won't say, how many of you know at least one scientific method song? Really? What was there's a PBS Kids show, we were trying to remember this last night. It's a little kid whose family are actually aliens and they live here, but their house is a rocket ship that converts to a house now. They're reporting back to their planet on Earth, but they've got a little song, the scientific method, ooh, something. Anyway, here's the thing that I want to disabuse you of, and I suspect you've all already had some of this bubble popped. Note that I made this plural, because too often, and we do this in middle school, my daughter's all irritated because in 4th grade they're learning the steps of the scientific method. She's like, Mom, that's not right. Yeah, just go with it for now. We simplify it, grossly oversimplify it actually, until it is a sort of cookbook series of steps. First you observe, and then you question, and then you research, and then you create a hypothesis, and then you test your hypothesis. And all of that is good, but it's not a straight line flow chart. It's more like a looping back on itself kind of diagram. So all science begins with observation, and that just has to be objective and factual. You know that already. Science seeks to explain, and those explanations come in the form of hypotheses, and hypotheses have to be tested or they're worth the paper they're written on. Interpretation, evaluation. Once you have results, of course, you have to interpret. And anybody who tells you that data stands alone and there's no interpretation is lying through their teeth. The minute you go from anything beyond numbers to explaining the numbers, you are interpreting and you are putting your spin on it, And we all have our own biases. We can't avoid them. The best we can do is recognize them. Anybody who tells you they have zero biases is a fool. From our evaluation of data derived from testing, we can come to conclusions. And in science, it's critical that those conclusions be shared with other people who are thinking about these things so that there's discussion, so that there's further testing. One of my favorite quotes from, I have both dead and living scientist crushes. Brian Greene, who wrote Elegant Universe, is my living physicist crush. He's awesome. I so want to go out and have coffee with him. Best quote ever about science and the scientific method and how we seek to disprove things in science. He said, I've been working on string theory for 30 years, and every morning I wake up and I come to work and I try to break it. Every morning I come to work and I try to break the thing that I've been working on for 30 years. Because and I know you guys, 3 of you had Berger last year and had her for bio. And I know she talks about the fact that science doesn't prove anything. It disproves things. We seek to disprove. We seek to break it. Well, if that's true, if this statement is true, then if we do this, this is what should happen. Now let's try that. Oh, see? We didn't break it yet. What we expected to happen happened. Questions on any of that? We're going to stop here because I think I have a premonition. I don't have a premonition. I got an email that we're going to have a fire drill in 2 seconds. When we come in on Monday, no, Tuesday. We're not coming in on Monday. We're coming in on Tuesday. When we come in on Tuesday, we're going to talk about models and their use in physics.